Fine. So yesterday I think we created a bank server, right? But then when we used it, okay, we saw something like the output for the, fine, like the client is able to give some commands, but the response is not coming back to the client. Instead, it is coming on the server. Okay, fine. Our bank server is running there. Fine. The method on bank, all those objects, everything is working on the server side. Okay. So system.out, fine. Our output here is mainly it's a problem about all the output going to system.out. Okay. Fine. So what should be done? Fine. So for that we can just take inspiration from what has been done by the throwable class. Okay. If you look at the throwable class, what they have done, we have this method called print stack trace, right? One of the methods in throwable class, if you look at it, yes, you have a method called print stack trace. Right? This is a method which we have used also, right? Print stack trace. What does it do? Display the stack trace. Where? Where does it print this? To the standard error. And the output will always go to the standard error for this. Okay, it's like saying system.err.println, something like that. Okay, so this output print stack trace by default goes to system.err. Fine. But then if I want the output to go to some other place, what has also been done is this method has been overloaded to take as parameter a print stream. Okay, so you can specify a print stream, or you even have another overload for this where you can even specify a print writer. Okay, fine. So if you pass the parameter of a print stream or a print writer, then the output goes to that print stream or the print writer. Okay. If you have not specified, then it goes to system.err. Okay, so overloading of methods which are related to output, that's what is the option here. Fine. So first thing what we need to do is, yes, we can identify what are the various things which are giving the output, okay, and have those methods being overloaded, and then we'll have to use those from the bank clerk. Fine. So if you look at the account class, fine. Fine. In the account class, what do we have? We have, which are the methods? We have a method called display, without any parameters, returns void. Fine. This is giving output, but where is it giving? On system.out. So instead, what we can also do is we can provide a overload with print stream, okay, and with a print writer. Okay, for the output maybe. Fine. Just like display, the other methods, if we identify which are the other methods, there is also a method called print passbook. Recollect this. Okay, the other method is print passbook. This also to be overloaded similarly. Fine. So that's the change in account. Okay. We'll have change in the bank also. Yeah, in bank what have we done? Which are the methods which give output? Withdraw, deposit, they don't give output. Bank, again we have the display method, right? So display is taking parameter as account number currently, right? And this is what we have. In bank, there is a display. In bank, there is a print passbook also. Okay, fine. So I'll just show what is for display. So yes, in display we have this. So instead of this, we should have display which takes as parameter, long for the account number, that will definitely be needed, but additional parameter of a print stream for the output, and again overload again for the print writer. And this can be a print writer. Fine, so we overload like this. Similarly, I think there is another method called print passbook also in bank. See, this other method here is going to use the display method of account. It calls display method on account, but then it should pass the parameter. Fine, it should pass the print stream or the print writer. Okay, fine. Because what is the implementation display? No, we don't have a system.out here directly. We simply invoke the other method. But when we invoke the method, there we should pass the parameter. Okay, fine. So bank, fine. In bank also we'll have this change. So in bank we'll have method called display. We have the other method called print passbook. Fine. There's another method called list accounts. Fine. That also needs to be overloaded. So we first will overload these methods, and then these overloaded versions will have to be called from bank clerk. And in the bank clerk, yes, we are simply we do have the object of a response writer. Fine, we have that object, but that needs to be used when invoking the methods on the bank. From bank clerk we are invoking methods on bank. So when we invoke those methods on bank, we should pass that parameter, that this is where I want the output. Okay, so once we make this change, then the things will come. Okay, fine. So let's try those changes. Okay, fine. So we have to change account class, we have to change bank, and we have also to change bank clerk. Okay, it's mainly overloading and then invoking them properly. Okay, what we had done yesterday was the bank server, right? And this is what was done. Let's have the account.java first. Fine. Okay, so in account.java, what is the change? We will need import for java.io print stream and the print writer. And these are used for output. So we are giving option for anyone to take output on a specified print stream or a print writer. Okay, and then See these the method where we have used system.out, that's a method which matters to us now. Yeah, oh, we find system.out here, right? Okay, fine. So what I'll do here is I'll make a change like this. I'll just make it as print writer. Okay, and print writer is out, and where I've written system.out, I'll just make it out.println. Okay, so it goes to the specified print writer, which is coming as a parameter here. Fine, it goes to out.println. Fine, out is our print writer object. Okay, but then we want to overload this. Okay, so let's overload. How do we overload? Public void print passbook, right, with parameter as a print stream. Okay, if it is print stream, what we should simply do is we'll say, okay, we'll use the print passbook which we have done earlier, and parameter will be new print writer created from the print stream with auto flush true. Okay, and we can just simply invoke the earlier method. Fine. And here also, if someone says, okay, we have the print passbook to be invoked without any parameters. Okay, if you don't specify any parameters, fine, we'll use the print passbook with system.out. Fine, it's a print stream, so it will invoke the earlier method. No parameter specified. If someone doesn't specify any print stream or a print writer, where should the output go? I'll say it goes to the system.out. Fine. So we use system.out, which is a print stream object, so it will use the earlier method, but with the specific object of system.out. That in turn calls the earlier method by creating a print writer object. From print stream, it is creating a print writer. Fine. Okay, so similarly we have to also overload display, right? Yeah, that's a display method. Fine, this can be written for a print writer. So output is fine, output is like this, but then we overload fine, just same thing. Fine, call the display method with new print writer created from our print stream with auto flush true. And if not specified, we'll call display with system.out. Fine, we should just confirm that we don't have any and we shouldn't have any system.out. It's past as a parameter is fine, but system.out.println shouldn't be there. There's only one which is in a comment. and if you want we can just remove this so that if someone uncomments it can still be okay. I'm just changing, so if someone is uncommenting later, yeah, it should still work, right? Okay, so account, and we are done with this, and we could compile and check it is fine or not. Okay, so this compiles. Okay, anyway, we still have to do it later because we'll need to make other changes. We'll need to make change in the bank. Okay. Fine. So coming to all the methods which generate output, save method is okay, load is a fine. Then we have the open account doesn't generate an output, get account not for output, deposit is not for output, withdraw is not for output. We have the display method here. Yeah?
Yes, sir.
Okay. So this display method takes one additional parameter which is a print writer. Fine. And then that's what is passed to the account object. When we pass it to the account object, this is where I want the display. Okay, and we can just simply overload it. Instead of print writer, we have the print stream object. Okay. And this one, what we do is we simply call the display method. With account number and new print writer created from this with true. Okay. And similarly we have our display method without a print writer or a print stream. If that is the case, yeah, what we should do, we can simply call display with account number and system.out. Fine. Same way with print stream, print passbook also. And the next method is print passbook. Need to overload. Fine, pass that as a parameter here. Okay, and then and we do it for the print string. Fine, print passbook called for this given account number and new print writer created from this print string. So if not specified, we'll simply call print passbook with account number and system dot out. Okay, and let's check the other methods. Close account seems to be okay. List account, yeah, that's another one. Okay, it's going to be for out.println, right? Now in this for each, when you say account colon colon display, right, that's not going to work here. Because account colon colon display, this is nothing but you are using a consumer of account, it's going to call the default method, and this is going to call the default method, and we have to explicitly call, so we will have to write a lambda here in this case. Okay, but anyway, so given any account AC, okay, what was it, AC dot display with parameter as out, and we'll have to explicitly invoke the method. Okay, that's a for each. Yeah. Okay, I think so. Bank class, I think the changes are done, right? We'll just need to check io dot star. So print stream print writer import is done. Okay, fine. So this is also we can say. We'll just compile and check. Instead of count, let's now use the bank.java. Okay, that also compiles. Next thing is bank clerk. Okay, and let's come to the bank clerk. Let's go through that. When it's only from those command, I think we have command specific methods, right? What have we done? From run method we are calling these methods. Okay, acha. Oh, each command has its own method, right? How to handle? Okay, so each one is having a, for example, when we say open, yeah, it's calling what? Bank.display, right? Comma, we have the response writer, and we have got the response writer. If there is a print stack trace, yeah, we have said out here. Sorry, here also it is out, right? Because that's the parameter we have passed. It's a local parameter. The print writer here is a local parameter, not the instance variable from outside. Because enums are going to be static. Okay, they can't use those methods. They can't use the response writer. Okay, so we passed them as a parameter in the method, right? So parameter is there. And so it was display with out. Okay, ePrint stack trace also already has the out as a parameter. So if there was an exception, yeah, that was coming fine. Okay, it was going back to the correct place. Okay, but then if we have, okay, let's look at the deposit again. I have to just pass the second parameter for out here. And display, where we have display, yes, we'll have to use this. Print stack trace is already doing that. In withdraw, yeah, out.println is done, but then comma out. One more. And in close, I think the output is coming okay. Close should have been okay. In display, yeah, we have to pass another parameter. In passbook, that's about printing passbook. List again, and we have to pass the parameter. Save. Yeah, save. It's going to out already, and quit is okay. Okay, so that should be fine now. Okay, let's compile. Just check the import. We have the import. I think there's no change there. So this should compile. Okay. Fine. Let's run the code. We want to run the server. And yeah, we are passing what one is port number, right? 1024. We have the bank. Okay, so let's run this. Let me make it full screen. Yeah. Read the error message. What's the error?
Exception shared main. Java12 invalid class exception bank.bank.
Yeah, so it's talking about bank.bank. What is it? Does it read? Read further. It says local class incompatible. Stream class. Fine. Stream class serial version UID. That's talking about stream class serial version UID. When I say stream class, see what is happening here. It finds a file. It's trying to load and create the bank object. It's trying to load and create the bank object. But when it's loading and creating the bank object, what it is saying is the serial version what I had stored here doesn't match with the serial version UID. Recollect, if you change the definition of any class, right, the serial version UID computation may change. Okay, so it's saying, okay, we got that serial version UID which is in the stream, which is in the file is like this, whereas your local class serial version UID is this. What it currently computes for bank, the serial version UID is coming out to be this, but when I had saved it, when the bank was saved, it was saved with this serial version UID. Okay, so they don't match, so I can't load this, I can't create the object from this. Okay, so what you can do here is, we know we have not made a structural change, and there's no structural change, so it should be fine to load that old class as it is. Fine, we would like to load that data, right? So what we can do is we can specify whatever is the serial version UID which is already stored, we can't change there, right, inside that file. So we'll pick that serial version UID and make it for our local class. Fine. So in bank, we'll put this as the serial version UID. Bank currently has this as the serial version UID. If we make it this one, they will match. Okay. What is from the stream is that. So I would like to make it to match with what was in the file. Okay. And so let's make this change. So this is to be done for bank. So this one is saying serial version UID equals So let's go to the bank.java. This is bank.java, right? And okay, so if you want to introduce have your own serial version, now that's what is the case. Fine, we can define private long static, it has to be static also, and long, private static and long, and we put serial version UID equals, it's of type long, let me put a L again and a semicolon. Okay, fine. So we use this in the bank and save it, and let's compile and run again. So we compile bank and let's run. It's still a problem. That has computed to a different value. What have we done?
Same.
Private static long serial version UID equals. So for bank.bank, it should be this. We compiled, huh? Bank.java. We did compile, right?
Yeah.
Because now it's giving something negative value, a different serial version UID. Okay. See, okay, there's also a command called serial var. Serial version, and can say, I can just say bank dot bank. Okay, I don't know, should be able to take dot dot slash pen minus CP. Does it take minus CP? Minus class path here to just put full name. Okay, so for some reason it's saying private static. Oh, we didn't declare final also, right? We need to say private static final long. Okay, it needs to be private static and final. Let's compile. Okay, let's run. Yeah. So the error for bank.bank has gone, but we still have an error. Now this time it's with the bank.account. See, there's no problem as far as the bank serial version UID is concerned, that matches, but while loading bank, I also have to load the accounts from the bank. Okay, and there it says, oh, that account class, right? Bank.account, local is incompatible. What is there in the stream is this, but what I find locally is this number. Fine, serial version UID again mismatch. So we also have to update the account class. And we'll also have to update account class. Okay. Just the way we did for bank, because we modified, see what we did was, our change was we added more methods into the account class, we overloaded those methods. Because of that change it has affected. Serial version UID doesn't compute to the same value because it's a new definition. Yeah.
ऐसा नहीं हो सकता कि अपने खुद से पिक करे serial UID को.
It is checking that what I had saved, is it the same class definition? It will compare the serial version UID. When we had saved, serial version UID was saved in that file, whatever was there. We didn't write, we didn't specify our own serial version UID. We let it be computed. And it was being computed and was being, and that's how it was compiled and saved. Fine, that's how it was compiled and saved. So, so what was, when it was saved at that time, serial version UID for account was this. So what has been saved in that hdfc.bank file? Account has been saved with this serial version UID. Okay, but because we have made changes, now when we compiled after making the changes of overloading those methods, fine, we made those changes, we overloaded the method. So after that change, the serial version UID which the compiler has now put is this one. Sorry, here it's this one, 147996 and also. And so that's the serial version UID which has now been seen in the class file. The class file has this serial version UID for account, whereas the account which was saved was with this serial version UID. So what we are now doing is, in the account we are saying, okay, we want this as the serial version UID for our account class. So we'll pick up the account serial version UID which we have found in the file hdfc.java. Find hdfc.bank, that's a file where the serial version UID is saved. Okay, so the old serial version UID which was used earlier when it was saved was this one. Okay, so let's update the account class. Okay, what we introduce is a static variable final and long, okay, equals this, and it's a long type, so L. Okay, now we compile and that should work. Okay, now we run this code. Okay, yeah, the server is running now. Okay, and then we do the, let's create those TCP client. CD Java901/src Java-cp.bin. We have the not fine, it is net.tcp client, right? 127.0.0.1 1024. Okay, and let's see list. Yeah, the output comes here now. And the problem which we had was the output was going somewhere else, was going on the server. It's coming back to the client. List, we can just ask for passbook for 2011201. Ask for passbook, and passbook comes here, right? Okay, fine. So you could try other commands as well. And so now the things are working fine. The output is coming to the correct place. And see, with quit it will come out of the loop for the bank clerk, but it would still be connected. So we'll have to use Control C there. Okay. Fine, we can just, so let's push this code. didn't push yesterday, right? Okay, and so finally we could make our bank server to work, and so now we have a proper working bank server, right, which is multi-threaded. We could actually be trying multiple clients simultaneously being serviced. We have done that with Eco server, right? So with multiple clients. Okay, so now let's continue with some more concepts of the thread class, some more API from the thread class. Fine. So earlier, I think what we have seen in thread classes, we have seen the various kinds of properties. Fine. Thread object separate from a thread of execution, and we understand that thread object is nothing but an object through which the corresponding thread of execution can be controlled, and you can change something there, and it will have effect, right? Let's see the effects which can be there. Yeah, some of the methods which we had seen were okay, properties. Yeah, what were the properties? I'll just put the names of the properties rather than giving the get and set method name. The properties were name, and you have a get name and a set name method. Fine. Then we have priority. Okay. And there's a get priority, set priority. Okay. We have the daemon setting, is daemon and set daemon. Fine. What are the properties? There are some properties which are read only. And for example, you can say is live, so this is read only. Okay, fine, it's read only. Is alive, right? Oh, sorry, alive. It should be alive, not live. Alive. Is alive, right? That's a method. So alive is a property, but it's a read only. You don't set it. Yeah. What are the things? ID. You don't set the ID, but you have read only. There's another property called what was it? Uncaught exception handler. And we have the get set method for this. Anyway, we also have a static method which is for the default. This is what we have on the thread object. Okay, fine. What else was there? Property get set or get only, something like get or get set methods. Huh? That's a static one. Fine. There's a stack trace. We have a get stack trace. It's only get, right? We have the stack trace. So only a get. Fine. It's not for set. It's get. On the individual thread object, you can just say get stack trace and get something out of it. Yeah. Fine. Any other get methods which are non-static? Static means that's not on the object. Fine. These were the things I think we have seen so far. Okay. Fine. We saw a few other methods. We saw about, oh, there's one more. There's a state, get state. Fine. There was those state of a thread, new, initially new, then becomes runnable. Fine. Then it might become waiting, timed waiting, or blocked, and then finally it will be terminated. Okay, so state also is a property. It's a read-only property, and only get method, get state. Okay, then we saw some methods which would take a thread into a waiting or a timed waiting state. What were those methods? We had these methods called, one was join, fine, join without parameter, join with parameter where we specify millisecond values, or we have join with parameter millisecond and integer for nanoseconds. Fine. This would take it into, the first method takes it into a waiting state, the other two method take it into a timed waiting state. Waiting, timed waiting state. Okay. Other method was sleep, which is going to a timed waiting state. See, there's another way of a join and a sleep. See, I'll just show you one enum here. Sleep, yeah, sleep takes as parameter long milliseconds, right? Or you can have sleep with milliseconds plus integer for the nanoseconds. Fine. The join, if you want, there's another way you can do a join. See, these methods are on the thread object. Anyway, the sleep is without any thread object, it is a static method. Okay, fine. We have a separate, there's one more package which is related to concurrency. There is a package called Java.util.concurrent. Java util concurrent. Okay. See, because most of the places, if you look at it, right, you'll find, oh, it talks about methods and methods being used with wherever time is needed, some time interval is needed, Fine. It will always talk in terms of milliseconds or milliseconds and plus nanoseconds, right? Okay, so many milliseconds and plus so many nanoseconds. Fine. So timing always has been given like this, but we've got various units, right? So if someone says no, I want to do something for 3 minutes, then you need to do it at computation and use milliseconds for that. Compute the milliseconds and then use it. Fine. Instead, what we have here is in the java.util.concurrent package, there is a enum called time unit. That's an enum. Time unit is a enum with constants like what are the objects of time unit? So it says nanos. It's nano or nanos. We can confirm the spelling actually. Fine. Same way it would say millis or milliseconds. It might be full name. Fine. Okay. Or you have seconds. Second or seconds. I'm not sure whether they have used plural here. But we have this enum called time unit, and this enum has a method. It has these methods. Okay, like I've just mentioned a few of the time units, but there are other time unit. Fine, it would go up to maybe it goes up to day, probably no, so many days, or hour is definitely there. It goes to seconds, minutes, hours. Okay, fine. Or maybe we can just quickly have a look in the API.
Yes.
There is a enum here called time unit. The enum is time. U is capital. Okay, if you look at this time unit, okay, what are the enum constants? Yeah, we have up to days, right? So it's in plural, that's one thing. So even microseconds, milliseconds, minutes, nanoseconds, seconds, and that's how they've written. Okay, but if you look at the methods, what we have got as methods here, we got some methods. If you look at the methods on the instance, you can say, okay, convert and all those things are fine. But what I'm looking for here is a method called sleep and a method called join. I think they had the join also.
Sir, time join.
Wait is there.
Time join.
Static method. Let's check the static method. Which one?
Time join. Yeah.
Yeah. We have the time join and the time wait. Sorry. Yeah, method name is not join, it is timed join. So we have the timed join where you pass thread as a parameter. So if I see how we use this, how it makes it slightly convenient probably is you don't have to do that computation anymore. Fine. So if you want a sleep or something, fine, you could say time unit. Oops. And you could use like this. You will say, okay, time unit dot, maybe I want to give 3 minutes, right? A sleep for 3 minutes. Minutes dot sleep 3. Fine, pick up that unit, on that call the method. Pick up that object, the time unit object, or you want to specify in hours something. Time unit dot hours dot sleep or timed join or timed wait, when we look at that wait method of object class. Yeah. So when we see, that's a method on thread, right? Join is a method. This was a static method, so I can use like this. But when it's a method on the thread object, like the method which is the join method. So if I have to use join method and I want to use time unit dot, I'll take the same example of minutes dot time join. Parameter will be the thread on which you want to, on which you would actually have been invoking the method, right? You would have said th dot join. So that thread and the value 3, something like this. Okay, wait was a method in the object class. So that object would be the parameter, so something like this. In the timed wait, the parameter would be the object and that amount of time you want. So you can pick up that specific unit you want. You can see. So if I say timed join, parameter is a thread. If I say timed wait, the parameter is a object. First parameter, and second parameter is the timeout value you want. Okay, fine. So a useful fine, we have a useful enum called time unit. U is capital here. Yeah. Okay. Fine, time unit, that's a useful thing, right? Okay, now let's look at another aspect. Okay, we saw those 3 methods which were deprecated, and there was a suspend, resume and stop. Those have been deprecated. So we said, okay, don't use a suspend, because who can decide? When to stop can only be decided by the thread which is executing, not some other thread deciding when I should stop. Okay, fine. So now, so there has to be still a mechanism by which other thread cannot directly say, okay, you stop, or you need to be waiting for some more time or something. Fine, other thread can't make it to wait as per its wish, but other thread should be able to give an indication that you need to wait now, wherever possible, go and wait. Fine, we might like to have a mechanism where a thread is able to indicate to the other thread, wherever possible you can just wait, or wherever possible you need to come out and terminate. Fine. So, there are those points we decided that within a method there can be some points where, okay, I am in a consistent state and I can do things like waiting, but I can't wait at any just any point of time. Okay. So in a method, fine. So now this is for the target. a target thread which you would like to suspend, or where you would like it to stop or do something. Okay. So for that mechanism, there is a mechanism which has been made available, okay, where a thread, so if we have something like this, we understand we have a thread object and we have a corresponding thread of execution like this. Okay. So there's another thread of execution which has control on this, maybe it knows this object, fine. So you don't suspend, but you can at least set some flag or something and say, okay, try to read my flag, fine, just read my flag, whenever possible do something about it. Okay. So we have something called interrupt. We have a method called, in the thread class we have got actually three methods. Let me explain. There are these three methods which go together. We have a method returns void, name of the method is interrupt. Okay. Another method which returns a boolean is a method called is interrupted. And a static method, this is a static method to return boolean, name of the method is interrupted. And the last one is a static method, not on the object. When something is not on the object, that means it's for the current thread only. It would work for the current thread. Not, you don't have a target thread on which you can do it. Okay. Fine. Just like, sleep, you can't make some other thread to sleep. You go to sleep. Same way, this one is not for some other thread, the last method. It's only for the current thread. Okay, it would work on the one who invokes the method. Okay. Now let's see how these three methods work basically. Okay, fine. So in a thread object, you can think that it has some boolean value which it is maintaining. It's maintaining a flag, a boolean flag, which is like whether it has been interrupted or not. So the flag will get set with interrupt. This is to set the flag to true. So interrupted flag is there which is set to true. So we can think there is an interrupted flag which is set to true when someone invokes the interrupt method on a thread object. Okay. Fine. Anyone can read the value by using the is interrupted. Any thread who has access to this thread object, right? If this is my thread object, any other thread of execution who has access to this can see, oh, it has been interrupted, or the flag is set or flag is not set. But whenever you set a flag, there should also be a mechanism to reset the flag. You should have a mechanism to reset the flag. But who should be allowed to reset the flag? Who is this flag meant for? It's meant for this, right? See, this is the execution sequence which is going on. It's meant for this one. This has to know that yes, someone wants me to be interrupted. Someone wants me to be interrupted. Fine. It's this one who should be reading the flag. Others can always read this. Is interrupted. It's a method on the object. Anyone who has access to the object will be reading it. But others should not be able to reset it. Okay. And therefore, we have the third method called interrupted. It's a static method. Fine. So if this guy is using interrupted, right? So this method interrupted does two things. It returns what is the current setting, as well as if it is set, if the flag is set, it will reset the flag. So resetting of flag is done by interrupted. Interrupt sets the flag, which anyone can do. It's because it's a method on the instance. Interrupted is a static method which would only be possible by the targeted thread. The current thread only can do it, right? Okay, so anyone allowed to set the flag, anyone allowed to read the value of the flag, fine, but resetting of flag and reading the value is done only by the current thread. Fine. So this sequence which is executing, because if you are doing on this object, it means you are targeting that particular sequence of execution. You want it to be for that. It's meant for that particular. See, this is, if anything to be done on this, it should be done through this object, right? So on this object, if you someone has set the flag, who has to read it? That guy ultimately has to say, yes, fine, I have read it, and take action. Okay, so this is a simple mechanism which has been available. Okay, now another thing could be, what can happen here is, just think of this thread here which is executing here. At some point what it might be doing is, it might have called a method called sleep, or it might have called a method called join. Now what's happening is, oh, it has called join method, it has got a sleep method, or some other method by which it has gone into a waiting or a timed waiting state, not the blocked state. Okay, there's a difference here. Blocked state is different. Okay, waiting or a timed waiting. It may even be a waiting for an IO operation to complete. So if it is blocked on some waiting or a timed waiting state, or blocked on an IO, and not the blocked state we are talking about. Blocking on IO is again waiting state. Okay, fine. You're calling read line, or that's a waiting state. You're calling accept method, that's a waiting state. Okay, fine. Blocked is something very different. We'll look at it later. Block means waiting for some lock, and we'll see what is that waiting for a lock. Okay, so if it is in a block, fine, if it's in a waiting state, and at that point if someone calls a interrupt, if it's in a waiting state and someone is calling interrupt while it is in a waiting or a timed waiting state, okay, the behavior is like this, that this thread would immediately come out of the waiting state. It would read the flag, and it not only reads the flag, this thread here would throw an exception. It would throw interrupted exception. And then continue. So interrupt on a thread which is in a waiting or a time waiting state results in that particular thread throwing an interrupted exception. Flag would be reset. An interrupted exception, it begins by throwing an interrupted exception. Okay. So if you are using a sleep somewhere, or interrupted exception is a checked one, you'll have to put it in normally a try catch kind of a thing. So that means you would normally be handling it. And so if you've handled, fine, you will be able to continue. Fine. Okay. Fine. So clear on this, these three methods: interrupt, is interrupted and interrupted. Okay, so so these three methods here, if you have to use any of those methods, if you have to use those methods, which one? Join, sleep, and later we even have a method called wait. Okay, we'll be looking at that method called wait, which is in the object class. If any of those methods is being invoked, it's going into a waiting or a time waiting state. All these methods have a throws interrupted exception. Join has a throws interrupted exception. We just saw that, right? We saw this method here. We have this method called sleep. Yeah. Look at the sleep. It has a throws interrupted exception. Fine. It's even in the time unit, and same thing even in the thread class. The sleep method has a throws interrupted exception. It has a throws interrupted exception. Fine. Same thing about join method. The timed join method here. Fine. Okay. Fine. So those methods which are normally for putting your thread into a waiting or a time waiting state, they have got a throws interrupted exception. Okay. Fine. So interrupt, normally it's about setting a flag, but thing is, if it is in a waiting or a time waiting state, then it results in exception.